Let me show you how to use the Maria simulator. You can download it from this address, so copy it, then paste it on web browser. Then choose sample materials. Maria simulator is there. This is a zip archive file, so as you download, you can unarchive that Maria simulator. This is the one you need. Specifically, mariasim.jar is the Java application, which is a Maria simulator. The others are just a sample program and then some guide like that. So we are going to use mariasim.jar. What I'm using now is a Mac computer. After downloading, if you double click, it will not work. It says that cannot be opened because it's from unidentified developer. It's the basic security check. So actually to run it, you need to do right click and then choose open, and then are you sure you want to open it? Just say open it. Then Maria simulator is running, and then it comes with this window. Then you have successfully downloaded and the Maria simulator is working. If you are using Windows, what you get is slightly different. So here in Windows, after you download it, right click on mariasim.jar and then choose open with. Then it shows which application is associated with a .jar file. You have to have a Java platform SE binary. If it's not so, choose more apps and then change it. Always use this app to open jar files. Press OK and make sure that the correct application is associated with a jar file. Then you are ready. So basically, after downloading on either Mac or Windows, double click if it runs. If it runs, then that's good. If it does not run, change the association. On a Mac, right click and get info, and then what you need to have is open with a jar launcher app. That is the one. If not, just change it. Then you can double click and run it. So once you have a simulator running, so you can test the program. So first, we need to create a Maria assembly language program. That is done through File and Edit menu. Then Maria assembler editor is there. So you cannot use any other third-party editor. So you should have to use the editor comes with the Maria simulator. So here we can write the program. Program should be written after a tab, and then you can write load x. X is a label, and then add y, and then store z, and then halt, and so on. So what you do is load data at address x, then add it with the data at address y. So loader means the address x, data at address x is stored in accumulator. Then with the accumulator, data at address y is added and result is stored back to the accumulator. And then store z means whatever is on a accumulator will be stored at address z. Program ends. Then we need to say what is address x, y, and z. And then that is give a label x comma, and then define data decimal 2, at address y decimal 3, and then at addresses z decimal 0 is there. So what you do in this program is load x means the 2 at address x is stored in accumulator, and then 3 at address y is added with the accumulator, which is a 5. 5 is stored at address z. So when you run the program at address z, 5 should be stored. Once you create the one, you need to save the assembly language program into a file. So file, save, and then choose where you wanna store. So let me store the program in download the folder. Let me name it as a first.mas. MAS is a suffix for Maria assembly program, so you should choose MAS and save. Then as you can see on my download the folder, first.mas is created, which is a Maria assembly language program. Once it's saved, choose assemble and then assemble current file. Then assembly works and then it creates a object program. So first.mex Maria execution program is there. In addition to that, symbol table is created as well. So symbol table means we have used the symbol x, y, and z. What's the value in x, y, z? Those are there. So what you need to do is after assembling that, choose a file from the simulator and the load, and then choose where you have created the program, and then first.mex you can load it. As you load it, the program is actually loaded in Maria simulator. At beginning address 000, the very first one is address 0, next one address 1, address 2, and address 3 is halt, and then x label x is at address 4, y is address 5, z is the address 6. So those are in symbol table. So symbol table shows that address x is 4, y is 5, z is 6, and so on. So based on that, now we can run the program. As the program is loaded, we know that at address x, which is 4, we have stored decimal 2. So you can see the memory map here. In memory map here, the very first row is 0, the column is 0, 1, 2, 3, 4, and so on. So at address 4, which is this column, we have stored decimal 2, so you can see decimal 2 is stored here. And at address 5, decimal 3, which is a hexadecimal 3, same thing is there. At address 6, which is z, 0 is stored. But as I run the program at address z, 2 and 3 are added, 5 should be stored. To run that, choose a run and then choose a run submenu. Then it runs and then it comes to halt. Now at address 6, 5 is stored, which is adding x and then y values stored as an address. The values from x and y are added and stored back to z. So program successfully runs through that.